Bubble sort, also known as sinking sort, is a simple sorting algorithm that performs comparisons on each pair of adjacent elements. The first two elements in the array, then between the second and third element, then the third and the fourth element, and so on, and interchanging them if they are in the wrong order. The algorithm is named in the way smaller elements bubble to top of the list. Suppose A is an array with n elements, from A0 to an-1. The bubble sorting algorithm performs as below. In the first pass, compare each of adjacent elements A0 and A1. So, for example, let's have these values: 29, 18, 15, 25, and 9. In the first pass, compare each adjacent elements A0 and A1. Then we'll compare A0 and then A1. So is A0 greater than A1? Yes, it is true. So we'll move the values from A0 to A1. Then the position now will be 18, 29. And we'll just copy this 15, 25, and 9. So now we'll compare A1 and A2. So let's copy 18. Then is 29 greater than 15? Yes, it is greater than. So 15, 29, 25, and 9. So next, A2 and A3. We'll compare this A2 and A3. So 18, 15, and 25, 29, then 9. 18, 15, 25. So is 29 greater than 9? Yes. So we'll swap these values, then we'll copy 9, then swap 29. So notice that in our first pass, the largest value of our elements is now located in our A4. So let's proceed to our second pass, where I is equal to 1. So 18, 15, 25, 9, and 29. In the second pass, compare each adjacent elements A0 and A1. So we'll compare A0 and A1. So is 18 greater than 15? Yes. So we'll swap these values where 15 and 18 is swapped already. Then we'll copy 25, 9, and 29. Next, we'll compare A1 and A2. So let's copy A0. So is 18 greater than 25? No, it is not greater than. So we'll not swap these elements, and then we'll just copy these elements. 25, 9, and 29. So next, we'll compare A2 and A3. Compare A2 and A3. So let's just copy values from A1 to A2. We'll compare A2 and A3. So is 25 greater than 9? Yes. So we'll swap these values where 9 and 25 are swapped already. Then we'll copy 29. So until A is equal to n minus 3. So let me just put what is our n. So our n is equal to 5. So since n is equal to 5, so 5 minus 3, it is equal to 2. So, and we'll have n minus 2. So 5 minus 2 will have 3. So a2 and a3. So 15, 18, 9, and we'll compare this. So is 25 greater than 29? No. So there will be no swapping. So let's just copy the values. And now we'll proceed to our third pass. Here, let's proceed to our third pass. Where our values are 15, 18, 9, 25, and 29. We've just copied the values from the second pass to this pass, okay? So compare each adjacent elements A0 and A1. Again, we'll compare A0 and A1. Is 15 greater than 18? No. So we'll just copy this and no swapping will happen. So 9, 25, and 29. Next, we'll compare A1 and A2. So let's copy first 15 and compare A1 and A2. Is 18 greater than 9? Yes. So let's swap these values and 9 is swapped to 18. So copy 25 and 20. So next we'll compare values from A2 and A3. So let's just copy this A2 and A3. We'll compare values from A2 and A3. So is 18 greater than 25? No. So there will be no swapping. And then we'll just copy these values. So next, we'll compare n minus 4 and n minus 3. So 15, 9, 18, 25. So is 25 greater than 29? No. So there will be no swapping again, and let's just copy these values. So notice that here we have our largest values here at the A3 and A4 index of our array. So 29 is now our largest value, so it is located on A4, and 25 our second largest value in our A3. So in the n-3 comparisons are required, and the third largest element is placed on n-3. So yes, it is located already. Our third largest element is placed on n-3. So a equal to 2. 5 minus 3 is 2. So 18 is in our index A2. So finally, we'll move to our fourth pass. So again, let's just copy the values. 15, 9, 18, 25, and 29. So here, finally, in the n-1 pass where our n is 5, then minus 1, it is already in our fourth pass where I is equal to 3. We will compare A0 and A1. So, is 15 greater than 9? Yes, 15 is greater than 9. Then we'll swap the values and 9 and 15. Then we'll just copy the following values. And now we'll compare A1 and A2. So is 15 greater than 18? No, so there will be no swapping. Then let's just copy all the values. And next we'll compare A2 and A3. So let's just copy the values. So is 18 greater than 25? No, so there will be no swapping again, and we'll just copy the values. So finally, 9, 15, 18, and 20. So is 25 greater than 29? No, so there will be no swapping happen again. So finally, in the fourth pass, they are now arranged on its proper order. Is arranged in ascending form. So therefore, in this pass, one comparison is only required. So we just only compare this value until such time that our values here are now sorted. Okay. So the first element A0 is apparently smallest element of the array. So it is now true, where 9 is the smallest element inside our array, and 29 our largest array. So therefore, array A of n elements from A0 to n-1 is sorted after n-1 passes. So in our fourth pass, where I is equal to 3, our array now is sorted. So that explains our algorithm in bubble sort. So bubble sort algorithm. So let's try to convert this algorithm into a program. So we have this online compiler. Then so this code will just ask for our array values. Then next, I'll create a program which will display our array values. So this part of the code will only print our array value. So let's run this. So now we'll have our bubble sort. Oh, sorry. So we have new variables which are J and temp also. So we'll add it here. And also X. We have that. So we need to have a code for sorting elements. So now we have our code. So let's try to run this one. So we have 29, 18, 15, 25, and 9. So now this is our code. So in the first pass, 15 and 18 is swapped, and also 25 and 29. So in the second swap, 15 and 18 remains, and also 9 and 25. Then in the third pass, 9 is swapped with 18, and 9 is swapped with 18, and 25 and 29 were just copied. And here on the first pass, 9 is swapped again with 15. Then our RA values now is sorted. So from 9 to 29 in ascending. So let's just simulate this code for a better understanding. Especially this one for our bubble sort. So let's have it here. So this will be our guide for our comparison. I mean passes. For our passes. So I equal to 0, then this one, so I is 0, then n is equal to 5. So 0, then 5 minus 1. So 0 less than 4. Is 0 less than 4? Yes, it is true. Then next, so next here, this one. So next we'll have this condition. If condition so j is equal to 0, then greater than a 0 plus 1. So a 0 is greater than a 1. Let's check this one. So is a 0 greater than a 1? Yes, since 29 is greater than 80. So 29 is greater than 80. So we have to swap these values. So next, we'll have j equal to 1. So here let's change j equal to 1 and 1 less than 4. Yes, so we'll proceed to this next condition. Then j is 1 already, so let's change this one. So a1 and a2. Since 1 plus 1 is 2. So now our value in a1 is 29. Then our value in a2 is 15. So let's change this to 15. Then is 29 greater than 15? Yes, so we'll have to swap these values and let's proceed to j equal to 2. So j equal to 2, and then is 2 less than 4? Yes, so we'll change this. J is equal to 2 already. So j plus 1, 2 plus 1 is 3. So a2 and 2 plus 1 is 3. So our value in a2 is already 29. So is 29 greater than 25? Yes. So we'll swap again. So 29 and 25, not 15. So here, our value is greater than, so 29 and 25 will swap these values. So now we have this one, and we'll go back to j equal to 3. So let's change this. So since our j is 3 already, so is 3 less than 4? Yes, it is less than 4. Then aj is already 3, and aj plus 1 is already a3 plus 1. So here we have a3 and a4. So a3 and a4 here. Is 29 greater than 9? So yes, 29 is greater than 9. So we'll have to swap these values. So our past one is already like this. Since 29 is greater than 9, we swap this value, so we have 9 and 29 already. So notice in the first pass that our largest value is located at our n minus 1. So okay. So j equal to 4. So 4 so is 4 less than 4. So this statement is already false. So we don't need to proceed to this condition since it is already false. So what will happen in our code is that we'll end this loop here. Then we have to go back to I++. So now we'll have this condition again. We'll repeat this condition where I is equal to 1 now, since we incremented I++. That's it. That's how we have our bubble sort algorithm. So in our first pass, we have 4 iterations. So 1, 2, 3, and 4. Okay? So from j0 to j equal to 3. So we have 4 iterations in our puzzle. So we'll just repeat this simulation until we reach pass 4, where our array now is sorted already. Okay? So that's it.